about chapter 7 triangles exercise 7.3. 7.3 first question. Two triangles are there in this diagram. See, which are they? They given as A, B, C is the first triangle and second triangle is D, B, C is the inside a second triangle. Both are isosceles triangle. In this way they given are two isosceles triangle on the same base BC. Both triangle are stand on a same base BC. BC is the base of this two triangle. Then A and D are the vertices. That A and D joining line extended and intersect the BC side. That intersecting point mark an alphabet T. Then P. Then what they ask you show that here are four cases they ask you to prove. What are the four things they ask you to prove? First triangle. Which triangle? ABD, this triangle, left side triangle, and ADC is a congruent triangle. First we want to prove that triangle are a congruent triangle. Second case what we want to do? ABP, this one left side big triangle, ABP triangle and ACP triangle are a congruent. That is the second case. Third case they saying that AP line is the bisector. AP line bisect means cutting which angle? Angle A as well as angle DC. Angle A is cut by AP line, angle D also cutting by AP. We want to prove that AP line bisect angle A as well as angle D. Then fourth case what we want to prove? AP line is the perpendicular bisector of our base line BC. BC line bisect means cutting by a AP line. That is the meaning of this question. We want to prove these things. So how to prove that? First in geometry topic proving time we want here four steps. First step is given, second step is to prove, third step is construction, fourth step is proof. First we started with given case. Given case, what are the information they gave? Two triangles are there. Which are the two triangles? ABC triangle and second triangle inside triangle DBC triangle are isosceles. They may given like that isosceles triangle. They are isosceles. That one we write isosceles specialty already marked there. Mark in the diagram. Sides are which side? AB side is equal to AC side of the first triangle. BD side and BD side is equal to CD side of the second triangle. That information also they gave in the question. Then next to prove. The second step is to prove. What we want to prove? That four cases one by one writing. Then extra construction note that. That's why what we want to do, construction step leave directly go through proof case. Proof case, how to prove what they ask in first case, that two triangle only consider. What are the two triangle mentioned in the first case? In triangle ABD and the second triangle is ACD. Look at that, where that one? ABD and AC, this two triangle case. How to prove any three conditions apply and they satisfying which property, then say that CPCT they are satisfying. These two triangle are congruent. So see what we can say, looking the diagram. So in this the two triangle case we can say AB side of the first triangle is equal to AC side of the second triangle, already given in the question. Next BD side of the first triangle is equal to DC side of the second triangle. That also given in the question. Then next what we can say, in both triangle AD side is common for both triangle AD side is equal to AD side common. Therefore what we can say, three conditions satisfied. So our triangle, which is a required triangle ABD, is congruent to triangle ACD by which property? All our sides, all three conditions represent the side case. Three side means which property? SSS property. Already first class we learned that one, SSS property. Then so first part completed. Then by CPCT what we can say here? Here we can say that angles also become equal. Which angle? AD line cutting angle A into two equal angles, which are the BAD CAD. Angles are equal. Angle BAD equal angle CAD by CPCT. We can say that one. Then here we mark this triangle as a first equation. Then later we need, that's why we mark that one. By same way what we can say, this one here angle BAP and CAP also become equal. Why? Because AP line cutting there. Same way we can say that, therefore we can say angle BAP is equal to angle CAPA. Vertex is cutting by a AP line also, we can say that. This is the first part. This first part completed. Next we go through second part. Second part, how to prove what information they ask to prove, that one just you take and prove. Second case, which triangle? Second case, triangle ABP. Second triangle name as ACP. In ABP and either that here this side left side, see ABP, right side ACP. What are the information we can say? AB side and AC side of that two triangle are equal. AB is equal to AC. That also given in the question. Next what we can say, AP line is common for both. See, AP line is common for this right and left side triangle. Next we can write AP is equal to AP common. Then just before step we writing that AP line cutting angle. This equation we can write angle, which angle? BAP. A angle dividing BAP is equal to angle CAP. Already we have proved that. So here also three conditions satisfied. Therefore our required triangle ABP is congruent to triangle ACP. There you by which property? Two side and one angle represent as a corresponding angle represent as a SAS property. There you mark it as a equation number 2. Then next what we want to prove here? We want to prove that AP line bisect cutting angle A as well as angle D also. We want to prove that. How to prove that means, this first equation and the second equation take. Second equation is greater than, see, second equation left side part, see ABP. First equation left side part is BAD, this small part. So ABP is greater. That's why second equation is subtracted with the first equation. We get that and which one AP bisect angle A as well as angle B. So next third case, what we want to do? First we write to first equation. First equation is triangle ABP ABD is congruent to triangle ACD. For mark it as a first equation. Our second equation is triangle ABP congruent to triangle ACP. This is our second equation. Subtract both equations. In which way we are subtraction doing? A second, if subtract a second equation, subtract a second equation with the second equation with the first equation. So second equation, left side is subtracted with the left side, right side is subtracted with the right side. Second equation, left side is triangle ABP subtracted with the first equation, left side is ABD is congruent to right side of second equation is triangle ACP subtracted with the right side of first equation is triangle ACD. Subtract means removing, adding means joining. Which triangle are joining, separating? ABP. This full triangle is removed with this small part, that means BAD triangle. Then which side will get in the triangle? DBP triangle will get in there. Therefore, instead of left side we can write it as that is equal to, removing time we get a triangle DB. Same way, right side of this subtraction AC, this triangle ACP triangle is removed with which triangle? ACD. Removing time, this full and this half, removing time, which triangle will remaining there? Triangle DCP will remaining there. We proved that these two small triangle become equal there. That means we can say that therefore what we can say, angle by CPCT, we can say that the two triangles are congruent. We proved that by CPCT. What we can say, BDP angle and CDP angle also become equal. It divide a P angle is equal to angle CDP by CPCT. See, D vertex also cutting by this line. That's why we proved that. Therefore, what we can say that AP line, AP bisect angle A as well as angle D also. We proved that as third case also. AP line bisect angle A also. Bisect means cutting and angle D also cutting and make it into two equal angles. So we proved the third case. What is the fourth case? Fourth case says that this AP line intersect BC line. That we want to prove. Fourth case. Fourth case, how to prove? Already we proved that triangle, which triangle? This small two triangle consider here. DBP already we proved is congruent to triangle DCP. They are a congruent triangle. If they are congruent means what we can say, which side are equal? BD side and DC side are equal. Next, what we can say, angle DPB and DPC are equal. So we can say that BD side is equal to CD side. Angle, which angle? DPB angle is equal to angle DPC angle. They are equal. Then next here they says the BC is a base line. Base line, they make a linear pair. See, BC is a base line. They make a linear pair angle. Linear pair angle means sum of two angle because how much degree? 180 degree. That's why linear pair way we write. I write here remaining part. Linear pair writing time angle. So in which order? DPC plus DPB is equal to DPC plus angle DPB is equal to 180 degree. Reason it is a linear pair. Then see, just before step we write DPC and DPB angle are equal. That's why instead of this DPB angle place we can write angle divide because both are equal. DPC is equal to 180. Now how many times DPC are there? Are 2 times. So adding time 2 times angle DPC is the equal 180 degree. Right and left side 2 table use and cancel. 2 table 2 110, 2 table 180 90 tens. That means angle DPC is equal to how much in it? That means here which is the vertex? P vertex. The P vertex represent as how much degree? Now that means hence what we can say, AP line perpendicular bisector means it to make how much degree? 90. We proved that it to make AP line make how much degree? 90. Perpendicular bisector of the BC. Therefore, what we can say, AP is the perpendicular bisector of which side? BC side. That is the fourth case they ask to. I hope you can understand this question. Then next we go through second question. In second question, they given us one isosceles triangle. Name it as ABC is an isosceles triangle. AD is the altitude of that triangle. We want to prove that AD bisect BC line. Same way, second part they say is that AD bisect angle. Second question of that is there. They given us a triangle ABC is there. So we can draw a triangle ABC. Which type of triangle it is? An isosceles specialty. Two sides are equal, which is that also given in this question. AB side and AC side of the isosceles triangle are equal, and AD is the perpendicular bisector. That also they mentioned in the question. Perpendicular bisector there bisect the BC side. Then prove that two cases we want to prove. Show that what we want to do, AD perpendicular bisect BC side. Same way, second part they say is AD bisect which angle A. These two things we want to prove. How to prove that AD is an altitude? It divided into ABC triangle into how many triangle? Two triangle. Which are they? ABD. Second triangle is ADC. The two triangle consider any three conditions apply. Say that both triangle become a congruent triangle. By CPCT, what we can say here, right? To divide into two AD line bisecting BC side. That's why BD side and DC side of the two triangle become equal. There, hence we proved that AD bisect BC side. AD bisect BC means the angle also AD line divide the angle A also. Which are the angle divide into two equal angle? Which are them? Angle BAD and CAD also become equal only. That is the procedure. So here also what we want to do, first given case, what information they given there, triangle ABC is an isosceles triangle. Isosceles triangle. Isosceles specialty AB side is equal to AC side. Then AD is the perpendicular to AD is the altitude. AD is the altitude. In this way they given there. Then next what we can write to prove. How to prove that what we want to prove. First case we want to prove AD bisect BC. Second case we want to prove AD bisect angle A also. These are the two cases we want to prove. Then third step, construction step, note that directly we go through proof. Proof case, here AD bisecting them divide into two triangle. Which are the two triangle? Triangle ADB. Second triangle name it as ADC. What are the things we can say? AB side is equal to AC is already given in the question. Next, AD side is common for both triangle. AD line is side is common for both triangle. Then here see perpendicular bisector means to make how much degree? 90 degree. Which angle? Angle ADB and angle ADC, both of them make 90 degree. That's why here I continuing. That's why what we can say, our triangle ABD is congruent to triangle ADC by which property? See, AB side, AB and AC represent, AB represent as the hypotenuse of this right angle triangle, and AD represent as one side of this triangle, and angle D represent as 90 degree. So 90 degree is there, hypotenuse is there, any one side is there. Such a property we call it as RHS property. So we can say these two triangles satisfy which property? RHS property. How to get once again AB represent as, with respect to this left side triangle, AB side represent as a hypotenuse, and AD side represent as one side of this right angle, and angle D represent as 90 degree. RHS property full form right angle. Here right angle, which angle? 90 degree. H represent as hypotenuse, which is the hypotenuse of this triangle AB side. S represent as any side, which is the any side AD side is. Same way right side case also. AC is the hypotenuse of the second triangle, and AD is the altitude any side of that same right angle triangle, and angle D represent as a 90. That's why it's satisfying a RHS property. So what we can say, therefore what we can say, BD side is equal to DC side by CPCT. Hence we proved that what we proved that first case AD bisect which side? BC side. Second part, how to prove? This is our first part. Second part, how to? Already we proved that here triangle ABD is congruent to triangle ADC. AD bisect to BC. That's why AD line cutting angle A into two equal angle, which are the angle BAD is equal to angle CAD. So these two angle also, A vertex also become equally. Therefore what we can say, AD bisect angle D, also AD bisect angle A also. Hence we proved that question. I hope you can understand this one. Then next we go through third question. Third question, they given us two triangles are given there. One is a ABC triangle. Second one is another triangle, PQR triangle. Two triangles are given and their median also they gave in that question. Third question, two triangles are there. First triangle name as ABC, and AM is the altitude of the ABC triangle, and AB side and BM side are equal, and AM is the altitude of that triangle. So one more triangle they given as PQR triangle. In this PQR triangle, PN is the altitude, PQ side and QN side are equal, and PN are the altitude, that also become equal. In this way they gave information, and then afterwards we want to show that which triangle? ABM triangle ABM is congruent to, with respect to second triangle PQN are congruent. Second case we want to prove full triangle, that is ABC triangle is congruent to second full triangle, that is PQR triangle. How to prove? First given information, first we write. What are the information they given? That ABC, in ABC triangle, here which are the sides are equal? AB and BM. Here here what they ask to prove there, here in triangle, two triangle are there, ABC and triangle PQR, which side AB and side AB and BM, and which is the altitude AMR equal to PQ, side PQ and side PQ and side PQ and QN side, and which is the altitude PN altitude. They are equal. No, they are equal. Here AM are the altitude. Then to prove case, what we want to prove? Two cases we want to prove. What are the two cases? Triangle ABM is congruent to triangle PQN. Next, second case we want to prove triangle ABC is congruent to triangle PQR. These two cases we want to prove. First, what they ask to prove, that one we want to start. So proof, construction not there. So directly first case in triangle, which are the triangle they mentioned, that two triangle we consider, triangle PQN consider. Then these two triangle, this small two triangle consider, three conditions apply, then which property they satisfying, and they are congruent triangle, first we prove. So what are the information looking there we get from the diagram? AB side of the first triangle is equal to PQ side of the second, that's why here one line is marked there. Next, BM side is equal to the QN side of the second, that's why two lines are marking there. They are given in the question. From there we get this information. The next altitude AM and PN are equal. Reason they are the altitude, that also given in the question. That's why our required triangles. Therefore, what we can say here, I writing it. Therefore, our required triangle, which is our required triangle ABM, is congruent to triangle PQN, by which property all are sides condition. So SS three are sides, that's why we can say they satisfying SSS property. Then next second case how to prove? Which are the triangle they ask to prove? That two triangle, which are this big triangle ABC and PQR. So in that two triangle, consider triangle ABC and triangle PQR consider. What information we can say? AB side of first triangle is equal to AC side of the second triangle. It is given in the question. Then for a first case already we proved that BM and QN are equal. They are the half of part of our big triangle. So that's why what we can say, BC and QR also become a reason. Already we proved here we proved that they are equal. BC and QR are equal. Then two sides and the including angle. Which are the including angle? Angle B is equal to angle Q also become equally. Therefore, our triangle ABC is congruent to triangle PQR, by which condition? Two side and one angle represent as including angle represent as SAS property. That are the question they ask to prove. I hope you can understand this third question. So our chapter is completed. Exercise 7.4 is deleted syllabus. Thank you.